Okay, so what I'd like to do is just kind of go over the first probably couple sections of chapter one, just to kind of get a good feel for what the chapter kind of covers. Um, so I want to go in through the e-text here, and we'll just kind of discuss via the book and kind of discuss kind of what they're talking about when they talk about computers, when they're talking about all the different things, and especially talk about RAM memory and basically how it kind of affects programming. Some of the different program, excuse me, some of the different programming languages that are out there today, that type of thing. So first thing you'll see is um, we basically come in here and it talks about an introduction and why program and so kind of one of the first things we kind of really need to get a handle on is the flow of logic, how we basically kind of flow through a program and the logic behind that, the kind of the steps to basically do this and this. It kind of steps through those things. So it talks about why program. Well, again, think of a program as just basically being a series of instructions that kind of step you through the different processes and how to get from point A to point B, but basically do it in a way um, that does it programmatically and automatic. So basically, what I'm trying to get to is you don't have to babysit a program. It runs itself and it runs. So anyways, just kind of think of those things. Okay, so we go on to the next page. And it talks about, yeah, again, some of the things I talked about there. It says the logic flow of the instructions, the mathematical procedures, the appearance of the screens, the way information is presented, so on and so forth. So, so that's kind of basically just some things we kind of need to cover and basically kind of get past. So the next section really gets into the computer system, hardware and software, kind of what we're dealing with there. Probably nothing new for a lot of us. We already kind of know the CPU and the RAM and all those different things kind of going on there. Um, So basically, inside a computer, we got this thing called a CPU. Now, CPU is kind of the brains of the operation, and it's basically stands for Central Processing Unit. And basically, there's actually two main chips inside there. You basically have your CPU chip, and then you got what's called your ALU chip, which your arithmetic. I have a hard time saying this. Arithmetic logical unit. And so, the CPU is the brain. The ALU does, it's basically think of that as being the calculator. So that's the device that does all the mathematical equations and all the things that basically uh, all the calculations, division, subtraction, trigonometry, calculus, all that sort of thing is basically done by the ALU. Now I want you to think about the and then talk about that down here as well. Here's the arithmetic and control unit. So what we have is we have input and output. So the CPU needs input. It does stuff to that, and then basically spits it out as output. So input could be your keyboard, could be your mouse, could be some type of um, input output device, one of those pins that basically writes on a screen, could be a touchpad, could be a touch screen. So any number of devices that are out there today that allow us to get data and put it in to the CPU. Output can be your monitor. It can be a printer. It can be, again, any number of devices there as well. There's just the there's really no limits of what could be output. Now the CPU, the actual CPU has no memory. You could tell it a joke and then turn around and ask it the same joke, and it would go, don't know, because it has no memory. It's good at basically going through logic. It's good at doing some type of calculation, but it basically has no memory. So what we need to do then is give it some memory. So what we have is this thing called RAM. And what RAM is think of it as kind of a dry erase board that the CPU uses to keep track of things. Okay, so let's say the CPU is doing a calculation, and it basically goes along and it's writing. Well, the RAM, being its dry erase board, kind of its scratch pad to kind of work things out, it runs out of room. So it runs out of room, and what happens is the dry erase board's filled up. What do we do? We got to erase it and start again. Well, it has to keep track of where it was at in the computation. So it just can't just stop the computation. It basically has to keep track of where it was at in the computation and go on. Well, there's some other memory in there called cache, C-A-C-H-E. And what cache is cache is kind of a placeholder. Where I'm at in the computation, you hold my place, kind of like a bookmark. So as it's going through this computation and basically starts going down the list, it runs out of room because the dry erase board's full. It says cache, hold my place. Cache holds its place. It clears the memory, so the dry erase basically erases that dry erase board. Then it goes back to cache and says, cache, give me where I was at. It goes back to where I was at, and it continues on the computation. We call that caching the memory. So basically, what kind of the the short version of the story is, the more memory you have, the less time it has to do an erase of that dry erase board and cache out the memory. So again, it seems like your computer will go a little faster. So that's basically what it's doing with Java programs. It has to load all those computations and the logic and the step-by-step process of where that logic basically lies, put that in the memory, and then we basically execute that particular program right out of memory. So that's basically what the CPU is. So we talked about the main memory is called RAM. RAM stands for Random Access Memory. Okay. The book goes into a little more detail as far as main memory, secondary storage, bytes and bits and gigabytes and megabytes and all those different types of new storage, the different storage things that are out there today. So it talks about input and output, and then we get into software. Okay, so software then is kind of like, it's input, and it probably could create output and even create more input, but it's actual lines of code that run in memory. So that's basically what a program is. When we load it into memory, it's now a series of code that can be executed. Okay, so programs, lines of code, can execute. Then we basically, on number 1.4, we get into the different programming languages. So it talks about what is a program. I've already covered that. It's just basically a series of commands, or executing different steps of what things that particular computer can do. If we had a robotic arm, we could actually write a program to move that robotic arm, which is basically setting a couple of switches on or off, and those series of switches being on or off will do certain things in a certain order. On page 7 is a list of, I'm not going to say all the programming languages, but kind of a good starting point of kind of the ones that are most commonly used. Basic is a beginning programmer's logic type of language we use. It's pretty much used for training. It's not really used for anything else. Fortran is kind of lost by the wayside, but it's basically more of a mathematical type of programming language. COBOL is still used today. It's primarily a mainframe programming language, but it's procedural language. And what procedural means is we just put a command here, another command, another command, another command, another command, and our program runs. It runs this line, then this line, then this line, then this line. It's procedural. Okay. C is it's an older language, but it's a little more powerful. It's basically a procedural type of language. And then it came out with C++, and we started getting into this thing called object-oriented programming. And we'll get more on that here in a little bit. And then we basically have Java, which is very highly object-oriented. We have JavaScript. Now these are little snippets of code that we can actually put in line of HTML and other web-based programming languages that are used to develop or some type of web pages is displayed. And this is actual programming language that can run right within the HTML. Perl is a very cryptic. I can't even explain of how you write a Perl program, but it's very cryptic, and you can rewrite it differently every time and have it do the same thing. I don't even want to go into the explanation, but realize it's there as well. PHP is a really easy language to learn. Once you learn Java, you'll know PHP, and you'll be able to then actually put PHP code directly in HTML. It executes. It can open and access databases. It can read files. It's a very, very powerful language. Not quite as powerful as Java, but it's a very easy language to use when trying to learn or embed it inside of HTML. Python is another object-oriented type of language, and it's web-based, so it's more web. It's there for developing web pages, and it runs kind of behind the scenes. Not familiar with Ruby. I've heard about it. I haven't read much on it, but it's again another object-oriented type of language that's out there, and I believe it's web-based as well. Visual Basic it was designed for what we call rapid application development, RAD or RAD, and that's primarily what Visual Basic is utilized for today. I need to get something out there very, very quickly. I can use Visual Basic, and it's basically there. Do we have permanent programming languages or programs written in Visual Basic? Yes. Yes, we do. But it's not quite as powerful as Java. It is object-oriented. VB.NET is, but again, kind of more of a training type of language. So then it kind of gives a history of Java. You can kind of read that on your own, but basically where Java came from, where it's at, all those kind of things, and applications and applets. And we'll cut it off right there. One thing I do want to say is, I forgot to mention this in the intro, but you will be required to come in to Midstate for the midterm and final. So, and I think that's kind of explained in the syllabus, but just realize you will have to come in for that. It will be on a Monday night. I don't have a specific date yet, but I will put it, I'm going to create a calendar, and the calendar will basically have all the different dates and things kind of going on there as well. So, okay, so that's it for the first part of Chapter 1. Take a look at that, read this chapter, be able to do the quizzes, so on and so forth. So, okay, we'll see you when I continue on with 1.5.